Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so we've done video tutorial on moving from Earth Engine to QGIS to Excel, and then we indicated that we're going to go to RStudio. So that was going to be the purpose. Now, remember, RStudio is predominantly a time series, but you can also work with rasters and vectors and all these things. So there is a spatial element to it. But for now, I'm just going to look at the cross-section capabilities or analysis that we can do. Remember, the whole idea was, from the beginning, was to create a data set that looks something like that. If the topography, the geographical images were time series, then this would be a panel data set. So we will have time series data for each of the variables over the 100 locations, and that's textbook time series, a panel data set. But we don't have time series for the topography. They are single image data sets. So therefore, we're going to work on a cross section. But cross section, time series, cross section regression equations. Okay, similar to time series, one or two different things. But for now, we're going to assume that we're going to use the time series packages and stuff in RStudio. Okay, so without ado, let's quickly. Okay, so as I said, remember when we download the data from QGIS, we export it and we save it as a CSV file. Then we open the CSV file and we convert it into Excel, and here we can make changes to it, and we can change the names, whatever. That's fine. And then we save it back into a CSV file. And it's sitting, it's not this one. Anyway, I've closed it now. Sorry, let me just open it quickly. It sits, there it is now. There we go, that one there. Okay, so what I'm going to do now is I'm going to go open my RStudio. And then I'm going to link the folder where the file sits in RStudio, because remember, that's important. Okay, so the folder that's displayed here on your right hand side, this panel here, must contain your data set. Okay, because otherwise the two won't be linked, and so when you call up the data set, it's not going to know where the data set is. So make sure that your data set sits within this panel. Okay, so what we can do is we can go to File, and we're going to say we're going to do a new project. Okay, a new project. So that's how you start. File, new project. Okay, let's save. Okay, we're going to go. Then you go to existing directory. Okay, you go to existing directory, and then you look for the existing directory. And here's my directory. Okay, and you just say create the project. Okay, so it's going to create it now. It's going to create it now, and you'll see it will in this. Okay, remind later. In this, you go to Files, and your folder will sit somewhere here. Okay, so remember we saved it as, let's just confirm, Snow Database Short QGIS. You see there's the folder, view from space. There's the data, Snow Base Short QGIS. Okay, it's a long word, but anyway, let's go for it. Where's RStudio? Okay, so it's Snow, MPQRS, the alphabet. Okay, let's have a look. Snow, climate, what is it called again? Oh, there we go. Snow database. No, it's not that. What is it called again? Snow database short QGIS. Yes, there it sits. Snow database short QGIS. There it sits. there it sits. If I double click on it, it says view file. Oops, it's okay. So it's used at the moment, it's open, etc. etc. So let me close it and save it. Okay, so it's using it in a different, yeah, so I can't open it now. So let's see now, file. I can't access it because, okay, so let's close it quickly. Let's close the whole thing, close everything, close all. Okay, so let's see it now, when it works now. Slow. Nope, still doesn't want to show me. Anyway, but anyway, the important point is, let's go quickly, new, recent, okay. Okay, so that's important, is when you code here and when you want to call up the database, there you go. You want to call it up, snow database short QGIS, there it sits. That must be in here. Otherwise, you must put the whole reference to where the location is, including the folder details, etc., etc. It's much easier if you link your project with a folder, and the folder is all the files are located here. Then it's quite easy to do. Okay, anyway, so that's important. So that's the first point. Create a new project. Okay, save, yes, and use the existing directory and highlight the directory where the data sits. Okay, that's important, and the data will then automatically, all the files related will become here, and then it's easy to work. So that's point number one. Point number two, there's a whole lot of packages that you have to download. Okay, so these are packages that I've installed. So I'm not going to reinstall it, but yeah, you install it, and then the library. There's a whole lot of packages that I run through my library. Remember, although your packages you install once, your libraries you have to activate every single time you use that project. Okay, so I'm just clicking run on it, and it will run, take its time. While the stop thread is there, it's still working. Wait until the stop thread is done, until the last one is done. Okay, all happiness, and I just rerun it again, and everything must be in blue. If it says there, it's warning, it's blah blah blah, don't stress too much, most of it's in blue. Okay, so now I've activated my package. I said, now the next important, once I've activated all my packages, and remember, this is not a final list. There's much more of them. Okay, but as you need packages, you just install them. Okay, if you can't activate it, then you have to install it using this language. Otherwise, just go library and the package name. Okay. So the next thing, once you've done all these things, you must bring your data into the project. Okay. So it's a CSV file. So I'm going to say my data, and this is the name I'm again similar to Erath Engine. You can use whatever name you want to give it. Okay, ping pong, yolly molly, doesn't matter. I'm using my data. Then you have this funny little thingamajig, smaller as with a I don't know what you call that thing, and then read.csv brackets, and then your file. Please remember to add the .csv, and header is true, meaning my CSV file has headers. Okay. So then you just basically run it, and then now it's activated. If the file, your data file wasn't located here in this file panel here, you'll get an error. Okay, so if it's not located here, you'll get an error because it doesn't know. It's looking up for the data file in here. So that's why I'm saying it's important that your data file sits there. Then I normally do a couple of things. I attach my data just to say I'm working with the data. And then I can have a look at my data by pressing my data. Okay, it will give all the data here. It will present all the data here. Or I can say view my data, and it will give my data there. Okay, so my data or view my data. You can see that they all are. There's the points, the coordinates. There's the point. There's the snow, sum, average, median, coefficient of variation. There's the max. And then there's my elevation, hillside aspect, etc., etc. So there's all my data, exactly as it is in QGIS. The data that I've generated in Erath Engine and QGIS. Okay. So let me close it. And you can see dimensions of my data. My data has 100 points and 100 rows and 31 columns. So it's 310 data. Well, not 310, less. But that's the dimensions of my data. Now, I don't have time series, so I'm not going to do the date. Okay, but this is typically when you have time series, then you will declare a date. But in my case, I don't have time series data, so I'm not declaring the dates. But I've added it in here just for interest sake. Okay, just for interest sake. Okay, but yeah, I don't have anything. I don't have a date. I can go structure of my data. Okay, so it gives you, it lists all the variables, and it says whether it's a number, or whether it's an integer, or whether it is a character or whatever. So please make sure that all your stuff is numbers or integers. Okay, if it's a character or stuff, you have to convert it from a character to a number. Okay, so it does give you what your numbers is, and then just the first couple of numbers of each of those variables. Okay, so that's the structure of your data. Then I'll just declare all my variables. Now you don't have to do this, but if you have a long variable name like mx underscore average, you don't want to type this because you may be prone to mistakes. So I just say, okay, I know in the data set, let's quickly go back to the data set, view data, let's keep it. You'll see it says sn underscore average. Now I don't want to keep on saying sn underscore, so I just make snow. Okay, so I'm just going to make snow. NDS, I'm just using that. So I'm just changing the names. I'm just changing them. So I'm taking a variable and I'm declaring it as a variable, and I give it a different name. So I just run them all. Remember blue, run. You want all these things blue. Okay, you'll see there in this top right hand panel, there's all your variables. Now it says it's a number, and it gives you the first couple of numbers. So you can go cross-reference it. So snow, so rain was 38, 35.9. So have a look and see. Let's go to rain. Rain is at the end. It's rain. Wind speed. Let's go to the rain. Let's go to participation. Yes. And so there is 38, 35.87. Let's go and have a look and see. 38, 35.9, 36.2. It's most probably just the order of it. But you can see that's plus minus correct. 36.2, 35.9. That would be rounded to 9. There they are. So those numbers correspond. Okay. Now I can plot my coordinates. So I just use plot my data. What is my data? My data is the data set. So you're telling him where to go and find the data. So go and find the data in my data set, and then plot the x, y, and plot the y. Okay, and I've declared the x code and the y code. I've declared it. So I do that. So I can click run, and there it is. It's just on a scale. Okay, so it's not actual where the data is. It just puts the y's on the y-axis and the x on the x-axis. So almost like a correlation. Okay, you can see there's no correlation. That's all fairly randomly distributed, although I handpicked those 100 points. Okay, so I can declare these two ones as coordinates. I can do that as well. And I'm going to, let's have a look if I press that. Okay, that's the first points, formal class spatial points. So I'm converting this x and y, I'm binding them. I'm saying they goes together, and they are called quotes, which is that quotes there, which is the same as basically that. And I'm converting it into spatial data points. Okay, so now I'm going to go to the structure of my spatial data points. Okay, you can have a look for that, and then I'm going to plot them. Let's have a look and see. There it is. Okay, there it's now plotted. Okay, I'm plotting them. This is just the size of it. Okay, this is just the size of it. So where I plotted it here, okay, I plotted it as a y and an x on like a normal graph. Here I'm actually plotting them in a spatial format, which I've done here. Here I'm converting my x and y. I'm converting my x and y into spatial data points. Therefore, it's actually plotting them in the coordinates, not in terms of a normal x and y plot. Okay. So just to make sure I've got all my points correct, I've got my region of interest, or I've got my 100 points correctly put. So that's just checking the data. So now there's a whole lot of things that I can do with the data. Okay, a whole lot of things. I can calculate a summary. Let's say I'm going to calculate a summary of snow. There's a summary of, remember, there's a median value of snow, minimum, the first quartile, etc., etc. So there's a whole lot of things I can calculate. I can plot the snow in terms of the level of snow and the different points. Remember, those points are now, I'm using points. Okay, so let me explain this quickly. In time series data, this will be your time period. This will be your date, monthly, annually, 1960, 1970, 1980, January, February, March, whatever the case might be. But we're not working with time series. Okay, so we cannot use time on our x-axis, but we have 100 points. So I'm converting, or I'm using my 100 points as time, if you want to take it that way. Okay, it's not time, it's 100 points. So here I'm labeling all 100 points from point 0 or point 1 to point 100. And I'm saying for each of those points, what was the snow? So you can see there's a point there. Okay, so we can zoom it. That point there, unfortunately, doesn't tell you which point it is, but that point, there's 1, 2, 3, 4, 5, 6, 7, 8 points that received, of the 100 that received that amount of snow. But you can see most of the locations received very little snow, if any at all. You can see it's very scattered as well, in terms of not the points itself or the locations, in terms of the volume of snow or the amount of snow it recorded. But you can see it's only 8 locations that received a lot of the 100 that received a lot of snow. Only 8 locations. Then there's these amount that experienced moderate or received a moderate amount of snow. But you see most of them, all of these received very little snow, if any. Most probably no snow. Okay. So that's what we do there. We can basically create a histogram of it. You can see the vast majority of snow, of locations received very little or no snow. You can see that. And there's the 8 that received a lot of snow. Okay, we can plot the normalized different snow index as well. Look there. Oh, well, sorry, plot it. And there they are. You can see it's only 2 that, according to this one, 2 that recorded a lot of snow. There's another 3 recorded some. But most of it recorded very little snow. There. Okay, I can do some plotting now. I can plot 3 graphs now. So I'm going to plot the snow, the rain, and the slope. Now it doesn't look neat. Let's export, or let's zoom it. There it sits. There's my snow for the 100 points. There's my rain for the 100 points, and there's my slope. You can see that if you look at this point here, if you go down, it's also a lot of snow, a lot of rain, and it's very steep. Have a look at this. So you can see the locations that recorded quite a bit of snow also were locations recorded sufficient rain, and were locations that had very steep slopes. And you can add in elevation, aspect, hillside, and all those things. Okay, so it's just analyzing the data. We can make the graph nice for snow. So I'm converting the snow into a time series now. And I'm using my locations as my time series, meaning I have a start at location 1, it ends at location 100, and my frequency is 1 location, meaning from 1 to 2 locations, from 2 to 3 locations, from 3 to 4 locations, from 4 to 5 locations, and so forth and so forth. If I only want to do every second location, I'll make it a second. If I only want every 10th location, I'll make it a 10th. So I'm converting my time, okay, my locations, I'm converting that into a time variable. Okay, I'm converting my 100 in a time variable, meaning 1 to 100, whether it's month 1 to 100th month, or year 1 to 100th year, doesn't matter. I'm converting it into a time period now. Okay, and I'm just going to plot that time period. Okay, and there we go. Let's just clear it again. Sometimes you have to clear it for the graph to look nice, and there it is. Again, similar to the point one, you can see there's the locations that recorded a lot of snow, and they're around point up, leading up, let's say from point 15 to point 30, maybe a little bit more than 30. Those locations recorded a lot of snow. Roughly location 15, if you want to look at it that way, to a point, let's say about 30. The rest, you can see the points here from about 30 to point 100. That recorded very little snow. Okay, so although this is time series, I'm interpreting as locations. And I can do for my normalized difference snow index. Let's run that. There it is. You can even say there it's only locations around the 40 mark. The rest. Okay, so slope, we can do the rest for slope as well. You can see the slope there, the first to 40, very steep slopes. And then from about 40 to 100, except perception with this one has very little slope. Remember, our snow locations lies in here. Remember, between 15, this one here, and between 30, this one here. So again, showing, okay, let's put them all together. Let's put them all together. There we go. Let's zoom it. Oops, why don't you want to zoom? Let's have a look and see. It's, I think, yeah, there we go. Let's zoom it. Limit. Why? Okay. I don't know why. Okay, so there we can see, which is this. This is snow, normalized difference in slope. You can see this where there's a lot of snow, quite steep slope, where there's very little snow, in red, you can see there's very little slope. So, seems like it. If we visually look at it, where the slope, where the snow fell, look at the data, it looks like the steeper locations are more likely to have snow than non-steep locations, flat locations. Most likely will not have no snow or very little snow. Steep locations most probably will have snow. But if the location is steep, it doesn't mean it will get snow. So it's a necessary condition, but it's not a sufficient condition. Because there's other variables also that influence snow, water, rain, temperature, elevation, and so forth, and so forth, and so forth. So this is just one-dimensional, simple correlation, but we have to include all the other variables. But it does give you a hint that slope is going to be important when we look at it. Okay? So we can now do all sorts of other things with it. We can do a scatter plot, for example, between, let's clear it again, sure, and we can run. There's a scatter plot between snow and rain. And you see this suggests an upward slope, although it's not very clear. I actually need to rather put in rain, I need to put in here slope. Let's look at that. And then I take in this and I convert it into slope. Okay, let's have a look and see. So it's not rain, it is slope, my data slope. Okay, I think I've done it now. Let's have a look and run it. There we go. You can see it's much more clearer in terms of a regression, a positive relationship. Here is time series, and we've got we're not gonna, what's this one doing here? Let's have a look and see. Oops. Okay, maxd not found. I haven't run maxd here, which is this one here. Let's see, run it now. Okay, I haven't converted max log. Okay, so don't worry about that. Scatter plots, we can do further scatter plots here. This is quite nice. Slope, there's a nice scatter plot. So this is a one-dimensional scatter plot. It just gives you a linear function here. But if you want to do a non-linear, there's a nice one we can do. Let's export that one. Let's zoom it here. You can see there's very little slope or very little relationship there, and then all of a sudden it increases. So it basically generates a correlation, but in subsections within your data. So not a correlation for your whole data set, but a correlation for subsets. So it indicates those locations where there's very little correlation or maybe a negative correlation, and those correlations where it's very positive, high positive correlation. And that you can see here, there's a number of locations where there's no correlation, but there are some locations where there's very high correlation. So it just takes, it's like a 3D correlation picture. Okay, so that's what we can do. We can do, if we have time series, we can do autocorrelation and partial autocorrelation. But obviously, this is points, this is cross section, so we're not going to do it. If we add time series, we can do stationarity test. We can do it. We can run it here. There we go. Okay, so it's max, not snow. So we can do an auto Digifuller test here. There we go. Digifuller test is stationary. 0.08 to accept the null hypothesis, which means our data is alternative hypothesis stationary. So it means that our data is not stationary because we must be smaller than 0.05 to accept the alternative. But that's irrelevant because we're working with we're working with cross sections, with locations, not with time. We can do moving averages. There's a whole lot of things. We can do a RIMA. So let's do an RIMA model quickly. There's our RIMA model. Okay, so that's our RIMA Y, our model that we've generated for our RIMA. So we frequency started frequency 1, we're going to time series, and now. Then we can do regression. Okay, so here's a regression function. We have snow, and then we put in minimum temperatures, slope, and hillside data is my data. So here we're starting, this is where we're starting to work with the data set now. Well, we've worked with the whole data set, but this is where we look with multiple variables. Okay, so far we've worked with 1 or 2 variables, etc. Here we're actually working with multiple variables, and you can expand. This is typical regression, but cross-section regression. Okay, so in fact you have to build in cross-section identifiers, but for now let's just leave it for now. So let's run a regression function. There it is. Let's create a summary of it. So it shows that minimum temperature is statistically significant. That's the 3 crosses. Negative relations, meaning the colder it is, the more snow. That makes sense. Nothing to dispute there. And there's the coefficient. As I said, it's statistically significant because the p-value is less than 0.05, or alternatively, the t is bigger than 2 or minus 2. The slope is statistically significant. Okay, definitely statistically significant, and it's positive. Meaning the steeper the slope is, the more the snow. But it's very small coefficient, very, very small coefficient. But it just indicates, yeah, so far. And then hillside, that's interesting to me. And this is correct, the minus and the coefficient is correct. But it's not significant at all. And I would have thought it is very, very significant. If you look at the images, you overlay the image, but this is now where the images becomes, as I said, you know, your images, the time periods of your images are not the same. And therefore, when you compare 2 images, it looks similar, but it could just be a look can be deceiving here. Here's the data. In fact, the data suggests it's not. And I found that particularly interesting. And that's why I've kept it in here, just to show you and stuff. So we actually have to exclude it. So if we exclude, let's quickly exclude it. So I'm going to copy, and then I'm going to cut it, and we run it again, and a summary. See, minimum temperature, so still stays the same. The coefficients don't change too much, 0.06, 0.0. So if I exclude it and include it, it basically influences very little. If you look at the R square, 4.5, and the R square 4.5. So including hillside is actually just rubbish because it doesn't influence the coefficients of the other variables. It doesn't influence the R values, the adjusted R's, the R's, F statistics still the same. So there's no point of including it. And I found that interesting, very, very interesting. But anyway, let's keep it in just for illustrative purposes. Let's keep it in. But as I said, it's very, there's nothing there. We can plot our regression. Okay, hit return, plot it. There is our regression. There is the residuals versus the fitted values. Okay, so there's a residual with the fitted values. There's a QQ plot with its line. We run it again. Okay, so we've done that. That's the fitted value. That's the standard errors. Anyway, you can run a whole lot of plots for it. We can plot the residuals and the leverage, and we can print the coefficients. Okay, we can run all sorts of other tests now, descriptive work that we can look, and then we can run the observed values and the predictive values, and we're gonna go and put the residential and the fitted, and then we can test it, etc., etc. So there's a whole lot of things that we can do in RStudio. This is just to give you an idea that we can work with the data now in RStudio and perform all sorts of additional things that you can most probably do some of the work in Erath Engine, but it's just so much easier to do it in RStudio, even in QGIS. Although I have R and QGIS installed, it's better to do it in R. Okay, so this is quick. I may have missed some steps. I may have not properly discussed or explained certain steps. But I said the purpose is just to show that we can do this in R, and there's a lot of things that we can do in R. And by the way, this is very little stuff this is very basic stuff that we're doing in R. Because we're working with cross-section, we have to look at cross-section identifiers and cross-section points and stuff here, cross-section stationarity. So there's a whole lot of things that we haven't done, which we should be doing if we work with cross-section stuff. But this is, again, as I said, I just want to illustrate to you that we can work within R. There's a link. There's a link between Erath Engine and R. And again, everything starts in Erath Engine. So this is just quickly what we can do in RStudio in terms of taking our analysis to the next level, working from Erath Engine. So thank you. Yeah, I hope you enjoyed it. This is still work in progress. This is by no means the end. We're going to return to RStudio, and we're gonna work more in RStudio as we go along, because this is the beauty of Erath Engine. It gives you data that you otherwise would not have access to. I mean, where would I get snow data? It doesn't exist in South Africa. We would not have snow data. But working with Erath Engine, I now have access to that data, which is beyond my imagination. I would never have had it. So that's why I enjoy working with R. It allows you to do things that otherwise you would not have done. And therefore you figure out things about your environment, your surroundings, that otherwise you would be oblivious to, you would not know. And therefore you can hopefully prepare better, make better decisions, make better policies and things like that. Don't want to go on a rant on those things. But anyway, okay, so this is just R. Next video tutorial, I'm just going to quickly do something on Geoda. Then we've done in Erath Engine, a bit of work in Erath Engine. We've done a bit of work in QGIS. We've done a bit of work in Excel. Now we've done a bit of work in RStudio. The final one I want to do is just a little bit of work in Geoda. So it's like tasters. It's just keeping you and pulling you in and keeping you on the journey. Keeping you on the journey. I want you to stay with me on the journey because it's fascinating. It's very, very fascinating. I like your company. Yeah. See you soon. See you soon. See you soon. See you soon. And with that, please remember to like, subscribe, send me a comment, share the buttons, press whatever buttons, press the damn buttons. The more you subscribe, the better it is for all of us. And with that, I'll see you on the other side.